Good afternoon, everyone. Uh, Today we're going to be starting off with um, Learning Unit 1. We're going to be starting off with Learning Unit 1 for Rsk4805. And please note that for our class today, I don't want to move too fast because registration is ending on the 31st of March. So we want to make sure that we accommodate as many students as possible because we're expecting a lot more students to enroll with us in the next week as well. So because of that, we're not going to be moving too fast. But at the end of the day, the classes must start because RSK405 is quite a lot of material that we need to cover as well. So we need to get on moving as soon as possible. So you will see that when it comes to how we are going to be approaching the assignments, I'll be making announcements on exactly how we're going to be approaching assignments as the assignment dates approaches as well, so that you know exactly how we're going to be approaching the different assignments. So the agenda today is to start off with the Learning Unit 1. So you'll see that for RSK 4805, for RSK 4805, you see that there are 4 topics that you need to cover. So there are 4 topics that you need to cover. And in each topic, this is where you're going to be finding the different learning units. And I think it's about 7 learning units that you need to cover. And in those different seven learning units that you need to cover, there are different chapters that you are also expected to cover from each learning unit as well. So please make sure that you go through the textbook based on the study guide provided by the lecturer, where you are given the topics and also the learning units and the chapters that you need to cover as well. Please pay attention to the study guide because there are certain sections that you're going to be leaving out in the textbook. So please take note of that. Over and above this as well, we are not going to be moving the textbook, although they revised the new textbook is a bit revised to make it a bit more sequential when it comes to the approach that must be done. But at the same time, always stick to the sequence in the text that is provided in the textbook and exactly in the study guide on exactly how you should cover the textbook as well. So please bear that in mind. So for topic 1, which introduces us to market risk. So for topic 1, which introduces us to market risk, we are going to be starting off with chapter 1 of the prescribed book. So for topic 1, which introduces us to market risk, we are going to be starting off with chapter 1 of the textbook. Please take note that for market risk, which is RSK 405, there is a lot of calculations that we need to go through. So please have your calculator on hand because you all expect that we're going to be going through or doing quite a lot of calculations for when we're covering RSK 405. So expect there to be a lot of calculations and preferably use a scientific calculator where with that scientific calculator, where you're opening brackets, you can see that you're opening brackets, and where you're closing brackets on your screen on your calculator, you can see that you're closing brackets there. It will be showing. Reason being, with past experience, I've noticed that many students, they struggle with the concept of BODMAS. Sounds like a simple concept, but many students do struggle with the concept of BODMAS because not everyone who studied risk management did study mathematics to on a continuous basis as well. So some of these concepts, they would have forgotten about them as well. So please try to get that calculator because once you have that calculator that shows you where you're opening brackets and you're closing brackets as well, it makes your calculations easier because the calculator itself will remember the concept of BODMAS on your behalf. So please bear that in mind. So I'm specifically talking to those students who are going to be using their HP 10B2 calculator to do this module. I've noticed that over the years, many students do struggle with using the HP 10B2 calculator. Reason being, with the HP 10B2 calculator, you have to work going backwards because you have to always remember the rules of BODMAS as well. So Are there any questions before we start off with chapter 1 as part of learning unit 1? Any questions? All right, so when we move to chapter 1 of market risk management looks at the introduction, where we look at the relationship between risk and return trade-off. So we're looking at the relationship between risk and return. And under that, they say, as a chief risk officer, it is your job to consider how the new venture fits into the company's portfolio. What is the correlation of the performance of the new venture with the rest of the company's business? When the rest of the business is experiencing difficulties, will the new venture also provide poor returns, or will it have the effect of dampening the ups and downs in the rest of the business? So companies must take risk if they are to survive and prosper. So the risk management function's primary responsibility is to understand the portfolios of risk that the company is currently taking and the risk that it plans to take in the future. So it must decide whether the risks are acceptable, and if they are not acceptable, what action should be taken as well. So when you look at the concept of risk and return for investors, on section 1.1, they say, we now examine the theoretical trade-off between risk and return when money is invested. The first point to note is that the trade-off is actually between risk and expected return, not being risk and actual return. The term expected return sometimes causes confusion. In everyday language, an outcome that is expected is considered highly likely to occur. However, statisticians define the expected value of a variable as its average or mean value. So the expected return is therefore a weighted average of the possible returns, where the weight applied to a particular return equals the probability of that return occurring. So the possible returns and their probabilities can be either estimated from historical data or expressed subjectively. So which means here they're saying, that's why you see that in investments, when you want to invest money and you approach a financial advisor as well, one thing they are always told not to indicate to you is exactly to promise you a particular return. They cannot promise you a particular return, reason being the returns are subject to what's happening in the market and the economy as well. So which means the return that you are going to be looking at and assessing as well, if it's going to be based on a projection, is deemed to be an expected return to say, on average, this is what we're expecting to happen, but it does not necessarily translate into an actual return as well. So to understand how one gets the expected return, or how the expected return of an investment is calculated, they refer us to table 1.1. Can you quickly read through table 1.1, which shows us the returns and the probabilities of earning the returns as well, and we'll go through those that calculation together to see exactly. So from the returns and the associated probabilities, how do we calculate the expected return? So from the information they give us the returns, and then they give us the probabilities as well. Please note that as we go forward in the module, whenever we are looking at, whenever we're dealing with returns, R is we're going to be using it to represent observed return, which is basically the returns that are going to be mentioned in the question. R with a bar on top, or mu, or expected return where there's an E and an R in bracket. All these are different notations which are used to represent expected return. And in short as well, PR, when we're dealing with returns, we're using it as a short form to represent the probability of returns as well. Please take note of this, because these are the common notations that are used when you're dealing with returns. So that if you see this in the assignments or in the textbook or in any other books as well, when you're dealing with returns, these are the common notations that are used when you're dealing with returns as well. So please keep that in mind. Now, when it comes to the expected return, the first thing that we're going to be looking at is analyzing a single asset. So if you're analyzing a single asset or a single investment, and in analyzing a single investment, then they ask you to determine the expected return. So the expected return generally would be given as, so your expected return is given as the sum of the observed returns multiplied by the probability of earning those returns as well. So the expected return is generally given as the observed return multiplied by the probability of return, and are going to be summing them up for the different scenarios as well. So this is how you are able to calculate the expected return. Remember, the expected return can be represented by this notation or can be represented by this notation. They all represent expected return. So keep that in mind. Are we on the same page? So which means moving on to the table 1.1 that they give us there. So for table 1.1, they give us those observed returns, and then they give us the probability of earning those returns. Please note, in the textbook, if you check in the textbook, when you're dealing with calculation of an expected return for a single asset, or when you're measuring the risk of a single asset, when we look at calculation of the standard deviation as well as the variance. Please note, over the years, there's an issue that we've had when it comes to calculation of the variance in the standard deviation. So when you're dealing with a single asset, please take note. To make your life easier, the lecturer basically says that instead of using decimals, if you're going to be, remember the observed returns, when you're dealing with these observed returns here, instead of converting them into decimals, then converting it back to percentages when you get the final answer. Because if you convert it into decimals, the lecturer recommends that you round off your figures to 8 decimal places. Although, when you look at the question paper basically says round off your in-between calculations to 44 decimal places and your final answer to 2 decimal places. Now, if you round off your answers to your values there or these returns to 4 decimal places, right? What we have noticed over the years is that if your observed return is less than 10%, it becomes very tricky now to round off these values to 4 decimal places, then back to 8 decimal places. So back to 2 decimal places when it comes to the final answer. So with the previous year's group, to make their lives easier, what we decided was it's a lot easier if we could just deal with these returns in full values, not converting them into percentages. So you will see that the calculation that I'm going to be demonstrating there is going to be based on these returns being presented in full values, not decimals, like what they did in the textbook, then it means that our calculation for the final answer becomes easier. Because remember, the values are already in full decimal places. Because remember, your in-between calculations would be four decimal places, and then your final answer back to two decimal places, which means that you are not going to end up losing out some values there when you round them off. So we're given these returns and we're given these probabilities. Now they're asking us to find the expected return. So which means there is a probability of 0.05. If you multiply that by 100, it means 5% probability. And this means 25% probability because you're rounding off. If you're converting decimals to percentages, it means that you're going to be multiplying these values by 100 to convert them into percentages. So which means 0.05 means there's a 5% probability that the return is going to be 50%. And then there's a 25% probability that the return is going to be 30%. And then there's a 40% probability that the return is going to be 10%. And then there's a 25% probability that the return is going to be minus 10%. And then there's a 5% probability that the return is going to be minus 30%. So given these returns and their associated probability, we need to calculate the expected return. So looking at this, remember we said to get the expected return, we're going to say if the sum of means you're adding up, and for each scenario, the observed return, we're going to multiply it by the probability in that case. So which means in this case, the first observed return is the return of 50%, and we're going to multiply that by the probability, which we are going to put in decimals. So which means this probability is the one that you need to put in decimals. So the probability has to be in decimals. So which means the probability is already given in decimals as 0.05. Plus, because you are said it's enough, isn't it? The second scenario, I'm just putting brackets to make it a lot easier. But remember with both maths, multiplication comes first before you add, isn't it? So I'm just putting it in brackets so that it's clear to you that this is the first scenario, this is the second scenario, and forward, moving forward. The next scenario, the observed return is 30%, multiplied by the probability, which is given as 0.25. Plus, you're summing up, the next observed return is 10%, multiplied by the probability, which is 40%, so it's 0.4. They're already giving us in decimals as 0.4. Plus, because you're summing up, the next observed return is 10%. Oh, sorry, it's 10%, then 40%. Then the next observed return is minus 10%, and the probability is 0.25. Plus, the next observed return is minus 30%, and the observed probability is 0.05. Please note, so this is how you calculate the expected return. Just to point out a note there, just to point out a note quickly, please note that when you look at these probabilities, the moment you see from the scenarios given, 0.05 plus 0.25 plus 0.4 plus 0.25 minus plus 0.05. If you add these probabilities together, they should add up to 1. Because probabilities and weights, if they are given in decimals, they should add up to 1. And probabilities and weights, if they are given in percentages, they should add up to 100%. So in this case, because the probabilities are given in decimals, if you add these probabilities, they should add up to 1. If they are not adding up to 1, it means that there's something wrong with the question or with your observation of the values as well. So given this information, it means we are being asked to find the expected return. So can you do the calculation of the expected return and let's see how much you get? Can you calculate the expected return and let's see how much you get? So how much do you get as the expected return? So how much would you get as the expected return from the list of these returns? How much would you get as your expected return?
Hi, Reynolds.
Yes, I'm listening.
I'm not sure if I did it right, but I got 11.50. Oh, no. I forgot the negative 30. No, I forgot that there.
Negative.
Hey, you see? No, it's fine. Let me do it again. Hey,
Okay.
hey,
So
the brain is
remember,
melting.
with market risk, this is usually the issue that many students have. They understand the concept, but they make small mistakes in the calculation there, which basically messes up everything. And the issue with this type of question is that, remember, for this single asset, we're being asked to calculate the expected return, right? The follow-up question can also be calculate the variance in the standard deviation, which means if you got the expected return wrong, the variance in the standard deviation is also going to be wrong, which means that you also end up losing marks as well. So the main idea behind market risk is you must always make sure that you master the use of your calculator. Very, very important. So how much do you get as the expected return?
Well, I got 10.00.
Yes, you should be able to get 10%. So you see that for the first calculation, you should be able to get 2.5 plus 7.5 plus 4 plus minus 2.5 minus 1.5, which should give you 10% being the expected return. Are we on the same page? Any questions? Anyone lost?
I have a question. Can you please clarify the RI here? It's still observed return. So if I see RI, it means R.
Yeah, it's just I. It basically, because sometimes RI is just saying it's an observed return of a certain asset. So in this case, it's basically an observed return of a certain asset as well. So the I at the bottom, it doesn't really make much of a difference there.
Okay, thank you.
All right. To avoid any confusion, we can even leave it out because it won't make any difference to the formula anyways, to avoid any confusion. But I prefer to say I because there are different assets that you're going to be taking into account. But to avoid any confusion, we just avoid putting the R there, indicating that whatever asset it is, this is how you calculate the observed return for each scenario. Are there any other questions? So you see that in the textbook, they did the same calculation, but when it comes to, they did the same calculation for calculating the expected return, but when it comes to the observed returns, they put them as decimals, which means your answer here is going to be a decimal. And when your answer is a decimal, it means you have to multiply that by 100 to make it a percentage. Because remember, your expected return is always going to be a percentage, which means if you do get the answer as a decimal, it means that answer you need to multiply that by 100 to make it a percentage as well. So this is how one would calculate the expected return of a single asset. Please take note that I'm specifically saying a single asset. So it's a single asset or a single investment, right? Next, they also look at quantifying risk. And here they say when you're quantifying risk, this is where you're looking at calculation of the standard deviation. So the quantification of risk is where you're looking at the calculation of the standard deviation. So there is a formula that they use in this case, where you look at calculation of the standard deviation. But with over the years, I've noticed that there is another formula that students commonly used when they were calculating the variance in the standard deviation when they were doing their undergrads. So when they were doing their undergrad level, there is a common formula that students use, because this formula basically straight away shows you exactly how to get the standard deviation. So there's another formula that is used, or that's been commonly used in calculating the variance in the standard deviation at undergrad level. So that's the formula that I'm going to be using to demonstrate, so that you don't feel like you are dealing with a completely new concept altogether. So generally, your variance, the variance, which sometimes is represented by this notation with a 2 on top. So whenever you see this notation with a 2 on top, it means you are referring to volatility. So when you're referring to volatility, you're basically saying that the volatility to the power of 2 is basically your variance. So if you see this notation, or you see this notation as you are going in the curriculum, whenever you see this notation, where there's this notation with the 2 on top on the power, or you should know that they are referring to the variance. Now, so for you to get to the standard deviation, please note that the first step is for you to calculate the variance. And your variance is given as the sum of the observed return minus the expected return that we have calculated. You square that, multiply by the probability of return. So for each scenario, we are going to say the observed return for each scenario minus the expected return that we have calculated here. You square, you put it to the power of 2, and then that answer you multiply by the probability of return. And for each scenario, we are going to be adding up all these scenarios together. And this is how we determine the variance. So that after calculating the variance, that's when you can now calculate the standard deviation, because the standard deviation which is represented by this. You see that there's a difference between this notation and this notation. The volatility on its own, without being put to the power of 2, is your standard deviation. And then your variance is going to be represented by that. Because we're basically saying the square root of whatever amount you get as your variance is what you're going to be getting as your standard deviation. So your standard deviation, if you look for the square root of a 2, it gives you this notation, which means that is going to be your variance. So this is how you calculate the standard deviation, given the variance that you calculate above as well. So for a single asset, if they ask you to calculate the standard deviation of a single asset, the first step, it means if you're asked to calculate the standard deviation of a single asset, step number 1, you need to calculate the expected return. That's your step number 1. Step number 2, you need to calculate the variance. Then finally, step number 3, that's when you calculate the standard deviation. So whenever they give you a question in the exam and they ask you to calculate the standard deviation, unless otherwise they give you the expected return, you have to calculate the expected return. So if ever they ask you for the standard deviation or they ask you for the variance, unless otherwise stated or they give you the expected return, you have to calculate the expected return first. Then after calculating the expected return, that's when you can calculate the variance. And if they're asking you for the standard deviation, then you have to calculate standard deviation on the third step. Are we together there? Which means from the given information, we are now being asked to calculate what? The variance, isn't it? So we say the observed return is the return for each scenario. for the first scenario, we said our return was 50% minus the expected return, which is what we calculated in step number 1. So minus 10, square that, multiply by the probability of earning that return was 0.05. Remember, you're summing up the ESA class. Is anyone lost on how we did the first one? Anyone lost?
Yes, sir. Please repeat that.
Remember, we have these observed. We calculated our expected return being 10%, isn't it? And then we were also given these observed returns for these different scenarios. So for these different scenarios, they also gave us these observed returns where we said the return of 50, 30, 10, minus 10, minus 30, right? So you have to go back to the first scenario where your observed return was 50%, right? So you're now going to say, for the first scenario, your observed return is 50 minus the expected return that we covered above, which is 10. We need to put it to the power of 2 according to the formula, multiplied by the probability. For the first scenario, the probability was what? 0.05. Are we on the same page? Then you move on to the next scenario. The next scenario was where we had an observed return of what? 30%. So you're going to say the observed return of 30% minus expected return of 10, you square that, multiply by the probability, which was given as 0.25. Plus, because you're summing up. The next observed return was an observed return of 10% and a probability of 0.4. So it's 10 minus 10 squared multiplied by the probability, which is 0.4 plus, because you're summing up. The next observed return was minus 10 and the probability of 0.25. So it's minus 10 minus expected return of 10 squared multiplied by the probability of 0.25 plus. The next observed return was minus 30% and the probability was 0.05. So it's going to be minus 30 minus expected return of 10 squared multiplied by the probability of 0.05. And this is how we're going to now calculate the variance. So if you're calculating the variance, how much would you get at the variance in this case? So how much would you get as your variance? So how much would you get as the variance? If you're afraid of making mistakes, if you're afraid of making mistakes in your
I get -10.
there must be something wrong. If you're afraid of making mistakes, rather separate your calculations by where the plus sign is. Where you do this calculation, get your answer, write it down to 4 decimal places. Do this calculation, write your answer to 4 decimal places. Do this calculation, write your answer to 4 decimal places, and do the next one, write your answer to 4 decimal places to avoid, if you're afraid of getting lost in your calculation, right? Rather separate this calculation by where the plus sign is. So that you do this part of the calculation, round off your answer to 4 decimal places. The next one, 4 decimal places. The next one, 4 decimal places. The next one, 4 decimal places. Then the last one, 4 decimal places as well. So how much would you get at the variance? Please cross-check your calculation. For the first calculation, you must be able to get 80 plus 100 plus 0 plus 100 plus 80. And if we add them up together, they should give you 360. Are we getting the same amount?
Uranus, I'm having problems finding the square root on this calculator.
We're not yet looking for the root, we're looking for the power of. So the 2 on top means you're putting to the power of 2. So which calculator are you using?
It's a Sharp EL738.
Do you see on your calculator, if you're putting something to the power of 2, do you see something on your calculator with the X with the 2 on top?
There is an EX2.
Can you take a picture of your screen? Can you take a picture of your calculator? Then I'll highlight it on and share it on the group, and I'll highlight it I'll highlight it for you.
Should
Just
I
take
put
a
it in the
picture.
group?
Sorry?
Should I put the picture on the group?
Yes, yes. Then I'll quickly highlight it so that you can see where which function it is to put a value to the power of 2.
No problem, I'll do that. Thank you.
On that calculator where the dot is, that's where your E of X is as well. So to access that, you are going to press second function first. Whenever you want to access the function which is in orange or yellow on your sharp calculator, you always have to press second function. So always press second function whenever you want to access a function which is in yellow.
Okay, no, thank you, man. Really appreciate it.
Okay. Are we getting the same amount of 360? Are we coming all right? Any questions? Anyone lost? So the last step would be the calculation of the standard deviation. And for the calculation of the standard deviation, we're going to be looking for the square root of the variance. What did we get as the variance? The variance was 360. So if the variance was 360, how much would you get as the square root of 360? Remember, when you're now looking for the square root of something, you're going to look for that function where there is a square root and an x. So where there's a square root and an x, this is how you're going to be looking for the square root of something. And how much would you get as your standard deviation? So how much would you get as your standard deviation?
I got 18.97.
Yes. So you get, in two decimal places, you get 18.97%. So to two decimal places, you get your standard deviation being 18.97%. Are we getting the same amount? Is anyone lost?
I have a question. So in the second calculation, the 30 minus 10 to the power of 2, is that 2 supposed to be there? Because I see the other
Oh,
ones.
my mistake. This is not supposed to be there. Sorry. My mistake here. This is
Thank
not
you.
supposed to be there. It's not
All right,
supposed to be
thanks.
there at all. All right. Any questions? Anyone lost? So we can move on. So for a single asset, if they ask you to calculate the expected return for a single asset, this is the formula that you use. And if they ask you to calculate the variance of a single asset, this is the formula that you use. And the square root of your variance would give you the standard deviation. So please take note of this, because this is a very common concept that the lecturer loves to ask in question number 1 of your exam. So in question number 1 of your exam, this concept, highly examinable. Common question. Can we move on? Moving on to section 1.1.2. Moving on to section 1.1.2. On section 1.1.2, they look at investment opportunities. And when you look at investment opportunities, they look at the alternative risk investments. And looking at these, they discuss the concept of calculation of assessing different investment opportunities. So they look at the concept of assessing investment opportunities. So you will see that for the different investment opportunities, you can assess the different investment opportunities by now looking how the return plots against the risk. So the risk, as measured by the standard deviation, would be plotted against the expected return of that investment, so that you can see exactly how are your investment opportunities plotting against your risk that you're taking. And as you can see, in general, the higher as you can see in general, which we are going to discuss later on, where you look at the relationship between the risk and also return as well. We're going to look at it in detail at a later stage. Now, when you look at assessing investment opportunities, they now say, consider 2 investments with returns R1 and R2. And the return from putting a proportion W1 of your money in the first investment and the proportion W2, which is given as 1 minus W1 in the second investment, is given by that. So which means the expected return of the portfolio is going to be given by that formula, which I'm going to explain. And then the standard deviation of the portfolio is going to be given by that formula, which I'm also going to explain as well. And to understand this better, they give us information regarding 2 hypothetical investments as well. But before we look at the hypothetical investments, let's look at the formulas to determine the expected return and the standard deviation of a 2-asset portfolio. And in this case, it's a 2-asset portfolio because we have asset 1 and then we have asset 2. So the 1 and 2s at the bottom there, they are basically indicating the identification of the asset. So this is asset number 1, and this is asset number 2 as well. So we are now analyzing a two-asset portfolio. So we're now analyzing a two-asset portfolio. And in this case, we have asset number 1 and asset number 2. So we're now moving on to analyzing a two-asset portfolio. We have asset number 1 as well as asset number 2. Now, W is going to be representing the weight of the investment. So the weight of the investment to the overall portfolio is going to be represented by W. So W represents the weight of the investment in the overall portfolio. Now, looking at this, it means when you're given this two-asset portfolio, and if you're going to be asked to calculate the expected return of the portfolio, so if you're going to be asked to find the expected return of the portfolio, the expected return of the portfolio is given as the sum of the observed returns of the different assets multiplied by the weight of the different assets. And this will give you the expected return of the portfolio. So the expected return of the portfolio is given as the sum of, for each observed return of the asset. So for each observed return of the asset, we are going to say the return of the asset multiplied by the weight of the asset. Now, remember we said we have a two-asset portfolio, asset number 1, asset number 2, which means since you are summing up the two assets together, it means I'm going to say, for the first one, I'm going to say the return of asset 1 multiplied by, remember we said the return has to be multiplied by the weight of asset 1, but because we are summing up, we're going to say plus the return of asset 2 multiplied by the weight of asset 2. So if it's a two-asset portfolio, it means you're going to be summing up by saying the observed return of asset 1 multiplied by the weight of asset 1 plus the observed return of asset 2 multiplied by the weight of asset 2. And this is how you calculate the expected return of a two-asset portfolio in this case. Are we on the same page? Any questions? Anyone lost?
Just go through the formula again. Thank you.
So now that we're dealing with the two-asset portfolio, we need to calculate the expected return of the portfolio. And we say the expected return of any portfolio is given as the return of the different observed assets multiplied by the weight of the different of the asset as well. Which basically means that if you are given a two-asset portfolio where we have asset number 1 and asset number 2, I'm going to say for asset number 1, the return of asset 1 multiplied by the weight of asset 1 plus, because you're summing up the values of the different assets, the return of asset 2 multiplied by the weight of asset 2, because you are summing them up together. So this is how you determine the expected return.
Happy, thanks.
So next, we need to so this is how you calculate the expected return of this particular portfolio. So if you go back to the information that they're giving us on this particular question, they tell us that we're given two hypothetical assets, and then they say mu. Remember where we said what we identified is mu? We said your mu is used to represent the expected return. Sometimes you're also given an arrow with a bar on top. It also represents the expected return as well. So if you see the notation mu, you should know that they're referring to an expected return. If you see the notation with an arrow with a bar on top, it also means that you are referring to the expected return as well. So they tell us that suppose mu of asset 1, which is the expected return of asset 1, is 10%, and the standard deviation of asset 1 is 16% per annum. Well, mu of asset 2, which is the expected return of asset 2, is 15%. And the standard deviation of asset 2 is 24%. Then they say, suppose also that the coefficient of correlation between the returns is 0.2, or in percentage term is 20%. So table 1.2 shows the values of mu and the value of standard deviation of the portfolio for a number of different values or different weights for asset 1 and asset 2. Please note, just like what I said when it comes to probabilities, the weights, they should always add up to 1 if they're given in percentages. If they're given in decimals. If the weights are given in percentages, they should always add up to 100%. So in this case, they say the calculations show that by putting up part of your money in the first investment and part of your money in the second investment, a wide range of risk-return combinations can be achieved, and these are plotted in figure 1.2, which we're going to analyze later on as well. So they are giving us table 1.2, where they are saying for the different weightings that are going to be allocating to asset 1 and asset 2, these would be the expected mu, which is your expected return. And this is how you'll be able to determine the standard deviation as well, which is given by that. So given this information, it means that if we are going to be looking at these two assets, which combination of weights would you want us to look at there? Pick any random combination of weights. Which combination of weights would you want us to look at for weight of asset 1 and weight of asset 2 to see exactly what the expected return or the resulting expected return would be and what the resulting standard deviation would also be as well? Which one would you choose? Any random. All right, we can choose a combination of 60% being the weight of asset 1 and 40% being the weight of asset 2. So if we put 60% of our investment in asset 1 and put 40% of our investment in asset 2, remember, 60% is 0.6 as a decimal, 40% is 0.4 as a decimal, which means 0.6 plus 0.4 gives you a total weighting of what? 100%. So which means now we need to check to see exactly, so what will be the resulting expected return and standard deviation under this combination as well. So just to recap, remember we said asset 1 has an expected return of 10% and asset 2 has an expected return of 15%. So given this, now we need to find out exactly, so what is going to be the resulting expected return of this particular portfolio of two assets as well. Which means to find the expected return of this portfolio, we're going to say is equals to the return of asset 1. Remember, they're telling us that the expected return for asset 1 is given as 10%. So the return of asset 1. Now, remember I said when you're calculating the expected return and the standard deviation of when you're calculating the expected return and the standard deviation of a single asset, remember I said for a single asset, you need to make sure that you round off your calculation to you need to use full percentages. So we said for a single asset, you need to use full percentages when you're determining the expected return as well as the standard deviation of those returns as well. And then I'll also further now say, if we are going to be dealing with a 2-asset portfolio, rather do your calculations in decimals, and then your final answer, you put it in full percentages. I'm just cross-checking that now. This one is 16. So which means for the first asset, remember we're given that the return for the first asset is an amount of, the return for the first asset is an amount of, the expected return is 10%. So it's going to be 10 multiplied by the weight of the first asset. Remember we said for the first asset, we're going to be giving it a weighting of 60%. And then the second asset, we're going to be giving it a weighting of 40% as well. So which means it's going to be multiplied by 0.6 plus the return for the second asset. The return for the second asset was given as 15%. So it's going to be 15 multiplied by the weight, which is equal to 0.4. So given this information, how much would you get as the expected return of this portfolio?
Hi.
Yes.
Hi, Reynolds.
Yes.
Got 12. Is that correct?
Yes. So if you check on the information that they're giving us there, on the memos, you should be able to get a figure of 15%. So, or 12%, sorry. You should be able to get a figure of 12% because if you check on the information that they're giving us there, for a weighting of 60% in asset 1 and 40% in asset 2, your expected to be equal to 12%.
Okay.
Are we together?
Yes.
Now we need to find the standard deviation as well. But before we look at the standard deviation, are there any questions? Is anyone lost before we move on to the calculation of the standard deviation? Are we getting the same amounts? So we should be able to get 12% here.
12%. Oh, okay.
All right.
Yes.
Now we need to calculate the standard deviation of a two asset portfolio. So now we need to calculate the standard deviation. So now we need to calculate the standard deviation of the two asset portfolio. Now, if you check in the textbook, they tell us that to calculate the standard deviation of a two asset portfolio, you are going to say the standard deviation of the two asset portfolio is given as the square root of the weight of asset one squared multiplied by the standard deviation of asset one squared plus the weight of asset two squared plus, so multiplied by the standard deviation of asset two squared plus 2 multiplied by the correlation coefficient between asset 1 and 2 multiplied by the weight of asset 1 multiplied by the weight of asset 2 multiplied by the standard deviation of asset 1 multiplied by the standard deviation of asset 2. And this is how we determine the standard deviation of the portfolio. And remember, on the question, they gave us the standard deviations. For asset 1, the standard deviation is 16%. For asset 2, the standard deviation is 24%. And then they also say, suppose also that the correlation coefficient, which is this one, which is represented there. So this is how you represent the correlation coefficient between the returns is 0.2. So given this information, we need to calculate the standard deviation of this portfolio. So which means we're going to say, we are told that the standard deviation of the two asset portfolio is given as the square root of the weight of asset 1 squared multiplied by the standard deviation of asset 1 squared plus the weight of asset 2 squared multiplied by the standard deviation of asset 2 squared plus 2 multiplied by the correlation coefficient between asset 1 and 2 multiplied by the weight of asset 1 I don't want to put it in the sequence, multiplied by the weight of asset 1 multiplied by the weight of asset 2 multiplied by the correlation coefficient of asset 1 and 2 multiplied by the standard deviation of asset 1 multiplied by the standard deviation of asset 2. And this is how you determine the standard deviation of a two asset portfolio. So the standard deviation of a two asset portfolio is given by this formula. So the standard deviation of a two asset portfolio is given as the square root of overally the weight of asset 1 squared multiplied by the standard deviation of asset 1 squared plus the weight of asset 2 squared multiplied by the standard deviation of asset 2 squared plus 2 multiplied by the weight of asset 1 multiplied by the weight of asset 2 multiplied by the correlation coefficient of asset 1 and 2 multiplied by the standard deviation of asset 1 multiplied by the standard deviation of asset 2. Please note, this part of the formula represents the covariance of asset 1 and 2. So if ever they ask you to calculate the standard deviation of a two asset portfolio and they give you the covariance, it means this part of the formula, they've already done it for you. So you need to check what information are they giving me on this question. Are they giving me the correlation coefficients or are they giving me the covariance? If they give you the covariance, it means this part of the calculation is done for you already. So you need to pay specific attention to the information given in the question. So which means looking at this, it's going to be equal to the square root of, remember, in our allocation, in our asset allocation, we said that we're going to allocate 60% to asset 1 and 40% to asset 2. So it's going to be 0.6 squared, because that's the weight of asset 1, isn't it? Multiplied by the standard deviation of asset 1. On the question, we said that because asset 1, the standard deviation was observed as 16%. So it's going to be 16 squared plus the weight of asset 2 is 40%. So it's going to be 0.4 squared multiplied by the standard deviation of asset 2, which they give us as 24%. So it's going to be 24 squared plus 2 multiplied by the weight of asset 1, which is 0.6, multiplied by the weight of asset 2, which is 0.4, multiplied by the correlation coefficient between asset 1 and 2 in decimal, they give it as 0.2, multiplied by the standard deviation of asset 1, which is 60, and the standard deviation of asset 2, which is 24. And this is how you calculate the standard deviation of a given portfolio. So how much would you get in the standard deviation of this portfolio? So we're going to take a few minutes break until 3:35. So can we take a few minutes break until 3:35? In the meantime, can you please try to attempt this question and see, let's see how much you get. So we're taking a few minutes break until 3:35. Then at 3:35, we continue with this particular section as well in calculating the standard deviation of a 2-asset portfolio.
Hi, Reynolds.
Yes.
Can you please just clarify there at the end, before the standard deviation of the 1 and 2 at the end? What is, I see it's a P, but sorry, I can't figure out what the rest of it is. It's P?
This is, you mean this one, this here?
Yes.
So it's your correlation coefficient of assets 1 and 2. So it's your correlation coefficient of asset 1 and 2. That's what it means there.
Okay, thank you.
All right. All right, can we continue? All right, can we continue? Now we're looking at calculation of the standard deviation. So which means to make your life easier in this calculation, rather separate your calculations by where the plus sign is. So you do a calculation with this part, round it up to 4 decimal places. Do a calculation with this part, round it up to 4 decimal places, and then do a calculation for this part, and then round it up to 4 decimal places. Then you add them up together, then you look for the square root of that. So how much are you getting for the first calculation? If you calculate here, how much would you get?
14,8722.
All right. I'm just going to break it down into these different components to make it easier for others to follow as well. So you should be able to get 92.16 plus 92.16 plus 36.864. Remember, if there's an extra zeros there, it doesn't really matter. When the idea is when you do this in between calculations, try to round off these figures to 4 decimal places as much as possible. Then, when you're now going to look for the square root, you're going to be looking for the square root of the sum of these values. Which means you're looking for the square root of 221.184. And the square root of that gives you an amount of 14.87 cents. Are we on the same page? Any questions? Anyone lost? So this is how you would arrive at the answer that they're demonstrating there. So this is how you arrive at the answer that they're demonstrating there, which is 14.87%. Are we on the same page? Any questions? Anyone lost?
I have a question. Will they, if we get a question like this, will these figures always be given? So
Which one?
like the expected returns from the investments that are 10% and 15%, and then the standard deviations, which are 16 and 24, and the correlation, which is 0.2. So like it says in
yes. For the two asset for the two asset portfolio, these figures are expected to be given. So for the two asset portfolio, these figures are expected to be given. Where they might try to make your life a bit trickier. So where they might try to make your life a bit trickier is where you need to remember the concept that for a two asset investment, right? It means you have weight of asset one. So it means 100% of the weight is equal to weight of asset one plus weight of asset two. So one, remember we said your weights should always add up to 1 if they're given in decimals, isn't it? So for a total weight of 1, it means weight of asset 1 plus weight of asset 2 gives you a total weight of 1. Let's say, for example, they gave us a hypothetical example. Let's say, for example, we were given that weight of asset 1 is equal to 60%. Right? But we don't have the weight of asset 2. So let's say we are given that weight of asset 1 is equal to 60%. Now, how do we determine the weight of asset 2? If you look at this formula carefully, if you solve this formula, it means if you're not given weight of asset 2, what can you do? You can solve for weight of asset 2 by taking weight of asset 1 to this side of the equation, isn't it? And whatever, if the amount that you're taking to the other side of the equal sign, if it's positive here, when it comes this side, it's going to be negative, right? So which means this is the same as saying, so this is the same as saying 1 minus weight of asset 1 gives you weight of asset 2. Because you've just taken weight of asset 1 to the other side of equal sign to solve for weight of asset 2. So 1 minus weight of asset 1, because remember, weight of asset 1, if it's carrying a positive sign here, when it goes to the other side of the equal sign, it's going to be carrying an opposite sign, which is the negative sign. So this is how you would solve for weight of asset 2. So which means if asset 1 is a weight of 60%, which as a decimal is 0.6, it means we should be able to determine weight of asset 2, because weight of asset 2 is given as 1 minus weight of asset 1, which is 0.6, which means weight of asset 2 in this case is 0.4. So that's the only other way when it comes to the weights that they can try to trick you, because if you're given a 2-asset portfolio, it means the sum of their weights should be equal to 1 if it's decimals, if it's percentages, should be equal to 100.
Got it.
Are we on the
Thank
same
you.
page? All right. So, in summary, they are now summarizing this combination of weights and returns. Remember, we have a combination of the weights and the returns and the expected return as well. Like, for example, if you have a portfolio where you have 0% in asset 1 and 100% in asset 2, the expected return is equal to 15%, isn't it? So if you have a portfolio where you have a weight of 0% in asset 1, 100% in asset 2, your expected return is 15%. So if your expected return is 15%, it means if you are now going to be plotting it on a graph where you are plotting the expected return against the standard deviation, what do we see? If you check on the information that they give us there, they're telling us that if you have 0% in weight in asset 1 and 100% weight in asset 2, your expected return should be 15% and your standard deviation should be 24%. So which means if we plot these two together to see exactly where they meet, you will see that when you plot these two together, remember we said we have, when it comes to, we have 15% expected return and 24% standard deviation. So which means when you plot these two together, we have, they are going to be meeting at this point. 15% is going to be roughly somewhere in between 14 and 16, which would be somewhere. Right. Should be this point here. It should be this point that corresponds to that calculation. And this point, where you have, yeah, roughly somewhere here. Which means if your standard deviation is about 24% and your expected return is 16%, you see that the expected return and standard deviation graph is going to be plotting somewhere here. Are we on the same page? Then, if you look at the calculation that we just did as well, remember we said if you have 60% in asset 1 and 40% in asset 2, the expected return should be 12%, and the standard deviation should be 14.87%. So 12% and 14.87 would mean that they should be plotting. So this is where we find 12%, and 14.87 is somewhere just below 15, somewhere there. So this is where they will be plotting as well. So this is how you plot the graph of the expected return against the standard deviation. So this is how they are plotting this particular graph. Are we on the same page? And the same applies where we looked at a scenario where we said if we that's the scenario that we, so the scenario that we looked at is this one, which means that the resulting returns will be that. And if you are looking at a scenario where we have 100% in asset 1 and 0% in asset 2, the expected return will be 10%, and the standard deviation is 16%. So you have 10% expected return and 16% standard deviation. So we have 10% expected return, which is here, and standard deviation will be 16, which is plotting somewhere there as well. Yeah, roughly somewhere there. So it will be plotting somewhere here, which is the 16. So it will be plotting somewhere the way you roughly find the value of 16 as well, roughly close to that. So do you see how we are plotting the expected return against the standard deviation? Remember, we said in Study Unit 1, we're going to be looking at what? We're going to be analyzing the relationship between risk and return, isn't it? So we're going to be analyzing the relationship between risk and return. Are we on the same page so far? So this is how they are plotting figure 1.2, which shows you the relationship between the risk and expected return. Now, moving on further, okay, we've covered this and that. We didn't skip anything there. Okay. So moving on further, we see that they also state that most investors are risk averse. They want to increase expected return while reducing the standard deviation of return. So which means most investors, they want to be able to increase the expected return while reducing the standard deviation of those returns as well, which means they want to maximize return and minimize risk. So effectively, they're saying, that statement is basically saying most investors, they are risk averse. They always want to find themselves in a situation where they are able to maximize return and minimize their risk exposures as well. So based on this analysis, we now look at the efficient frontier to say, so if the investor's goal is to maximize return for a given level of risk, now how do we look at and ascertain the efficient frontier? So when you look at the efficient frontier, I'm going to start off, before we look at what is given in the text, I'm going to start off by analyzing, using a simple hypothetical example. So we have assumed investments A, B, and C. So we're assuming these investments A, B, and C, and we're given the expected return against the standard deviation. So here the return is 10%, and here the standard deviation, let's say it's 12%, and here it's 15%. Then here we have let's say, for example, it's an amount of 18%. Now, if you are asked to choose between, if you're asked to choose invest between, so if you're asked to choose between investments A and C, which one would you choose then? If you're asked to choose between investment A and C, which one would you choose? So if you're asked to choose between investment A and C, which one would you choose and why? So investment C has a risk exposure of 12.5 and an expected return of 10%. Investment A has a risk exposure of 15% and an expected return of 10%. So which of the two investments would you choose and why?
C.
And why C?
I think the standard deviation will be lesser.
And lesser for the same return, isn't it? So in this case,
Yes.
one would choose investment C, isn't it? At the same time, if someone is asked to choose between investment A and B, which one or which investment would one choose? And why?
Think would advise them to choose B because it's got a higher return compared to A, although the risk exposure is basically the same. So
It's the same, right? So we choose investment B. Let's say they are asked to choose between investment B and C. Which investment would one choose there? It's not an exact answer. Why? Because the choice depends on investors' risk appetite. So it's not an exact answer because the choice would depend on the investor's risk appetite. Why? Because if the investor wants to invest in B, if the investor wants to take on more risk, isn't it? They are going to choose investment B. And if the investor wants to take on less risk, they're going to choose what? Investment C. So it all depends on exactly what the risk appetite of the investor would be. In simple terms, I'm not looking at it from a complicated case where you look at the where you look at the Sharpe ratio and all those other things as well. From a simple term perspective, from a simple hypothetical perspective, would say your choice between investment B and C will depend on the investor's risk appetite. If the investor has a high risk appetite, they want more risk, more return. And if the investor has a low risk appetite, they want less risk with a lower return as well. Ideally, from a simple hypothetical example, this is how the investor would be making that choice. So looking at this, it means in summary, we can say for investors, their goal is to maximize return for a given level of risk. So for a given level of risk, ideally, you would expect a rational investor to maximize the return for a given level of risk. And for a rational investor as well, ideally, you want the investor to minimize risk for a given level of return. So for a given level of return, you would expect the investor to minimize their risk exposure for a given level of return. And this is how you are saying that under normal circumstances, this is how you're expecting a rational investor to make their investment decisions. Are we on the same page? So the reason why I'm introducing this concept is mainly because it means if the investor's aim is to maximize return for a given level of risk, and if the investor's aim is to minimize risk for a given level of return, it means when you look at the graph of investment choices, the graph of investment choices is going to be found somewhere here. It's going to plot going somewhere there, which means these are the efficient combination of portfolios that they can invest in and leave out investment A. Are we on the same page? So when it comes to the efficient frontier, this is what they're trying to demonstrate in the textbook. So when it comes to the efficient frontier, this is what they are trying to demonstrate in the textbook when you look at the combination of those risks and returns as well. So when you look at the combination of those risks and returns, the efficient when it comes to the efficient frontier, this is what they're trying to demonstrate in the textbook. Because if you check now, if we go back to our example, remember we said there is different combinations of weights and expected return and the standard deviation there as well, which basically means that when you look at the efficient frontier, you're basically saying that how do we draw a graph which shows us where we are able to maximize the returns for a given level of risk and minimize the risk for a given level of return. So which means that in this case, it means when you're now drawing the efficient frontier, you are going to effectively leave out investment, this particular investment. So you're going to effectively leave out this investment. Why would we leave out this investment in the drawing of the efficient frontier? Because for this set amount of risk exposure, so for the set amount of risk exposure, you are better off finding yourself at this return and risk relationship than finding yourself on this risk and return relationship. Because at this risk and return relationship, you are able to get an expected return for the same amount of risk compared to being at this risk and return relationship. Are we on the same page? Which means ideally you would want your efficient frontier, if you're going to be plotting an efficient frontier, you would want your efficient frontier to be plotting from somewhere here going forward like that. Because if you plot it going in that direction, it means this is how roughly this is how you're going to be plotting the efficient frontier, because you're going to be leaving out this combination here, because for this combination, you're better off finding yourself along the efficient frontier here than finding yourself here, because if you find yourself at this point, this is the point where you're able to maximize your returns for a given level of risk. So now the question would be, what weighting are you going to be giving to portfolio A or to portfolio 1, and what weighting are you going to be giving to portfolio B, so that you're able to find yourself having this expected return for this amount of risk exposure? Are we on the same page? So effectively, this is what they're discussing when they're now referring to the efficient frontier. So the efficient frontier basically gives you that combination of expected return against the standard deviation, where you are able to maximize your return for a given level of risk and minimize your risk for a given level of return. Are we together?
Yes.
So moving on to improving on the efficient frontier, remember we said our efficient frontier is found, is basically found along there as well. We can also create a new frontier as well, where we are going to be borrowing from a particular source and investing those borrowings to earn a higher net return as well. So this is where you're looking at determining a new frontier, which shows you the relationship between the expected return and the standard deviation as well. So here, when you look at figure 1.4, they say when you're now looking at figure 1.4, point I, which is this point, where you're looking at the relationship between the beta, in this case, where you're looking at the relationship between the risk against the expected return. And then they say point I is achieved by investing a percentage in B1, which is basically a percentage in B1, which is basically found here, of available funds in a portfolio M, and the rest of the risk in the risk-free investment. And then point J is achieved by borrowing at this point where you have B, J, and then 1. So where this point where you have B, J, 1, and if you're going to be borrowing at this particular point, which is BJ minus 1, then you're going to be of the available funds at the risk rate and investing them in the M portfolio, which means this is where you are now going to be finding yourself where you're able to generate a return along this particular along this particular line here. So which means that this becomes your new efficient frontier. So looking at this, the main idea that they're trying to introduce us to this point is that when you look at this particular efficient frontier, if you want to have a new efficient frontier along this line, you are basically, if you want to be able to achieve this return at this point, it means you are going to be borrowing at a certain return or at a certain cost at a lower point, and then investing at a higher rate of return, which means that you're going to be borrowing a certain amount and investing it and to earn a higher certain rate of return. It basically means that you're going to be able to earn that net return, which means that your efficient frontier becomes a linear efficient frontier instead of it being curved as well. Are we on the same page? Any questions? Anyone lost? Let's
a bit lost. What does the B represent?
B is your beta, is also another measure of risk.
Okay.
B is your beta. Remember here, we have your expected return against your risk, isn't it? So your risk can either be based on your standard deviation, or it can be based on it basically can be based on a certain risk that you're going to be taking if you're going to be looking at what the risk measures as well. So which means looking at this, your B in this case is going to be, it's basically your risk measure, because it's, okay, when you look at the total risk being faced by a particular portfolio, your total risk is given as your systematic risk. We're going to discuss this. I think it's in the next section where we talk about the capital asset pricing model, where we're going to be discussing this. Because where we're going to be talking about the capital asset pricing model, this is where we're going to be talking about the beta and how it relates to the capital asset pricing model as well, and how it relates to the total risk of the portfolio. So your total risk is given as your systematic risk plus unsystematic risk. Now, your systematic risk is also sometimes referred to as your non-diversifiable risk. And then your unsystematic risk is also sometimes referred to as your diversifiable risk. And then your total risk is measured by standard deviation. So your total risk is measured by your standard deviation, which is represented by this sign. And then your systematic risk is measured by beta, which is represented by this B with a longer tail. So this is where you see that this notation and this notation, they are all measures of risk. But standard deviation measures total risk, and beta measures systematic risk. So which means the only time that we're going to be taking into account or worrying about systematic risk is where we're assuming that your portfolio is fully diversified, and the only risk that you're going to be worrying about is your systematic risk in that case. So that's the difference between this sign and that sign. Are we on the same page?
Yep, thank you very much.
All right. Are there any other questions? All right. If there are no questions, let's end here today. We're going to be ending at unit 1.2. In the next class, we're now going to be moving on to looking at the capital asset pricing model. And I'm also going to be explaining this concept as well to see exactly, so where does beta come from? And how do you measure beta as well? Because sometimes in question number 1 of the exam, they also they love to bring in questions which are to do with the capital asset pricing model as well. So you need to know exactly where does beta come from and how can you measure beta, and how are you able to identify the value of beta given the different ways that they can demonstrate the information in the question as well. So please take note of the timetable. So please take note of the timetable. And our next class is exactly 2 weeks from now. So please take note of the timetable. And in the next class, we are going to be continuing with unit 1, where we are going to be on chapter section 1.3 of the chapter in that case. All right, enjoy your weekends.